Hello everyone. On this video we will be looking at how to graph polar curves. Okay, so to do that we're going to first look at how we would approach it. Okay, so the graph of a polar equation, which is our polar curve, and our r, remember r is equal to x squared plus y squared, or you could make it r is equal to sine squared theta plus cosine squared theta. So it all depends on which form you have it in, but for the most part r is just going to be a function of theta. Okay, so that function consists of all points that we call P with at least one polar representation. And we'll call that our r theta. Okay, so let's give a quick example. Okay, and this video, if you still need like an update for polar equations, just go back and watch the video of polar coordinates. Uh-oh. Okay, so it follows the polar coordinates video. Alright, so let's say, for example, we want to describe the curve represented by the polar equation r equals 2. Okay, so if we wanted to just describe it, we have to first get an idea of what we're looking at, or what we're looking for. Okay, so remember, R represents every point 2 units from the pole. Okay, so remember the pole is just the origin. Okay, now the fact that we don't have a theta, because remember normally we'd have an r theta. So that tells us that it's r number of units from the pole, but theta units from the polar axis. Okay, but this one did not give us a theta. Okay, so that's why the r will represent every point. Now, if they gave us just one specific theta, then that would be completely different, but they didn't. Okay, so if you look, let me scroll that up a little bit. There we go. So we have 0, pi over 2, pi, and 3 pi over 2. Okay, so if we look at it this way, let's say that we know that this is r equals 2. Then that means that this is also r equals 2. And this is also r equals 2. And this is also r equals 2. All of these points are exactly 2 units from the origin. Okay, so what does that mean? R equals 2 just represents a circle, where every point on that circle is 2 units from the pole, or the origin. So really, whenever you have a graph r equals anything and they don't give you a theta, it's just going to be a circle. The only difference is that radius is going to vary. So if it was just r equals 1, it would be a circle with a radius of 1. If it was r equals 20, it would be a circle with a radius of 20. So whenever you're asked to describe a curve and all they give you is r, then that's all you need. Okay, it's just a circle. All right. So go ahead, and if you're still writing, feel free to press pause. But we're going to go ahead and go to our next example. All right, so let's say we wanted to sketch the polar curve of just theta equals pi over 3. All right, so just like before, normally we're looking for our r theta, but this time we didn't get an r. All we have is a theta. Okay, so before, just like you had r is equal to every point that's a distance of r from the origin, whenever you're given just the theta, that's just the graph of the polar equation consists of all points on the line that makes an angle of pi over 3. Okay, that's really it. So that means if you draw your xy, well, not xy, well, I guess you'd say your polar axis, then theta equals pi over 3 will look just like this. Okay, the only difference is it's not stopping at any particular point because you don't have an r. Okay, so if you had an r equals 1, you know that would eventually stop when you hit 1. Since there's no r, that goes on forever. So this would actually be your graph. All right, so this is kind of the way to look at it, where if you have theta just equals some pi over 3, then it would just be a straight line from the origin all the way up to that space. Or if you had negative pi over 3, it would just look like this. Okay, so this would be theta equals negative pi over 3. And I'm trying not to fill it in too much and make it confusing, but this is it here. Okay, so we're going the negative pi over 3 direction, but again, it would go on forever because they gave us no r value. All right, so hopefully that's making a little bit of sense. Let's move on to our next example. Again, if you're still writing, by all means, feel free to press pause. Alright, so let's say for this example, we want to sketch r equals secant of theta. Alright, So remember that r is equal to f of theta, or you can view it as f of theta. So you can also have f of theta equals secant of theta. The same way you can have f of x equals some function of x. Theta is just your parameter. Okay, now the one thing about this is this looks really, really complicated. But if you remember your trigonometric identities, you can make this a lot simpler. Okay? So that's our little remember note. Now to answer it, you know the graph r equals secant of theta. Let me clean that up. Can be converted. Since it is not immediately obvious. Okay, sometimes looking at it, you go, oh, I don't even know where to start on that one. It just looks confusing. Always think, how can I change it into something that's less confusing? Okay, so this is how we're going to approach this one. R is equal to secant of theta. That's what we're starting with. But we can convert secant of theta to R equals 1 over cosine of theta. Remember, secant theta is equal to 1 over cosine of theta. Remember those trig identities. Okay, so if we multiply both sides by cosine of theta, we have r cosine of theta equals a 1. I'm just going to say r equals, well, 1 equals r cosine of theta. Okay, so how does that help? This helps because if you think back, you have x equals r cosine of theta. So if x is equal to r cosine of theta, that just has 1 equals x, or x is equal to 1. And what's the graph of x equal to 1? It is just literally a vertical line through 1. So that's your 1. This is the graph of x equals 1. Okay, so sometimes sketching the graph is all about how you approach it. Okay, where you won't need to do a whole lot of work. And then there are other times where you will have to put in a little bit of work to sketch a graph. It's not always the easiest, but it's no different than creating a table to graph on an XY curve. XY coordinate plane. All right, so I'll show you what I mean on the next example. Again, if you're still writing, feel free to press pause. But we're going to go ahead and move on. So let's say, for example, you want to sketch the curve r equals 2 cosine of 3 theta. Okay, so this one's a little bit different. There's no little shortcut you can use for this one. All right. So what I'm going to do is show you the table that I created ahead of time. Okay, so we have our theta, and we have our r equals 2 cosine of 3 theta. Okay, so what we're going to do is we're going to plug in various values of theta until we get our point. Okay, so if we plug in theta equals 0, 2 times cosine of 3 times 0, or 3 times 0 is 0. Cosine of 0 is 1, so that gives us 2. What if we plug in theta equals pi over 6? Okay, so 3 times pi over 6 is pi over 2, and I chose that because that would give us 0. Okay, so what if we replace theta with pi over 3? Okay, so if you kind of notice the pattern, I'm picking denominators that will cancel with the 3. Okay, so that's why I'm picking pi over 6, pi over 3, something like that. Okay, and also ones that will give us pretty easy numbers, no big fractions or anything to deal with. So that's why I'm kind of carefully picking my values of theta. Okay, so if we plug in pi over 3, our r will equal -2. Okay, so what if we plug in pi over 2? Okay, 3 pi over 2, well, cosine of 3 pi over 2. Nope, 2 pi over 3, sorry about that. Oh, no, that is pi over 2. Sorry about that. That gives us 0. So what if we plug in 2 pi over 3? There we go, kind of looked at my values a little bit early. That would give us 2. Okay, so what if we plug in 5 pi over 6? That gives us a value of 0. What if we plug in pi? It gives us a value of -2. Okay, so all of the values of theta, if we plug into here, will give us these values on the right. Okay, I'll go ahead and give you a second to finish writing those if you are still writing them. Now what we're going to do is we're going to look at the step for graphing each point, or each polar coordinate. All right. So first thing we're going to do, draw a little graph here. We're going to look at theta from 0 to pi over 6. Okay, from 0 to pi over 6. Okay, when you have 0, you have a radius of 2. So when theta equals 0, you have a radius of 2. So it goes from, starts here, that's 0, 2. Then pi over 6 to 0. That means it starts here and it goes here. So that's how it looks to start. Okay, so what if we look at from pi over 6 to pi over 3? Okay, pi over 6 to pi over 3. Okay, we already see that the first half of it looks like this. Okay, we got it from here. Okay, so that's pi over 6. Now pi over 6 to pi over 3 is -2. Remember, -2, if you have a radius of 2, -2 goes this way. Okay? So it kind of looks like here. Okay, that's your -2 to pi over 3. No, -2 pi over 3. Okay, so what if we go from pi over 3 to pi over 2? So we're kind of slowly seeing how our graph is being built. Okay, so we have from pi over 3 to pi over 2. Okay, so we can see the first part of our graph looks like this. The second part of our graph looks like this. Now from pi over 3 to pi over 2, you have a radius from -2 to 0. So it goes from -2 back to 0. So that means it goes right back there. Okay, so you see how we're starting. We're starting with our first little loop where our theta was 0 to 2, and then it went from pi over 6 to 0. Then it went from there to here, and then it went from those two to the third one. Okay, so we're slowly building our graph. Okay, so a little bit more. We still have pi over 2 to 2 pi over 3. So let's move that up. Okay, so we see here where we're starting at. We have here to here, here to here, then we have from here to here. Okay, so from pi over 2, pi over 2, 2 pi over 3. Okay, we see 2 pi over 3, we go from a radius of 0 to a radius of 2. Okay, so that graph now goes from here to here. Because remember, this is our 2 pi over 3. Our theta's 2 pi over 3 is here, and we have a radius of 2. Okay, so what about 2 pi over 3 to 5 pi over 6? Okay, so starting where we went, remember that's our first graph. That's our second graph. That's our third graph. That's our fourth graph. Okay, remember this is from 2 pi over 3 to 5 pi over 6. Okay, 5 pi over 6 is 0, so 2 pi over 3 to 5 pi over 6 goes from a radius of 2 to a radius of 0. So this one goes right back there. Kind of fill in that a little bit more. Okay, so we can see our graph goes right back to 0. Okay, so now we just have to go from 5 pi over 6 to pi, which will show us our completed graph. Okay, so remember from our first graph, and went from here to here. Our second graph went from here to here. Our third graph, right up here, took us here. Our fourth graph took us here. Our fifth graph, you can see between 2 pi over 3 and 5 pi over 6, took us right back to 0. You can see from 5 pi over 6 to pi takes us from 0 to -2. Okay, which takes us right there. Okay, so it's not a perfect looking sketch. All of these actually should be equal in size. But if you're looking for a sketch and not a perfect drawing, this is how it will look. And if you just plug that into your calculator, R equals 2 times cosine of 3 theta, and put in your parameters for theta, you'll see it'll look somewhat like that. Okay. Now if you go from, this is from 5 pi over 6 to pi. Okay. Now the thing is, you can go from pi to 2 pi, you'll just trace the whole thing over again. Okay, so going from 0 to pi gives you your first curve. If you go any higher than that, it just traces over it, so it won't look any different. Okay, so remember, just a quick recap of what we did here. Excuse my crooked table. We just plugged in various values for theta. Okay, now between 0 and pi over 6, we went from 0 radius 2, so theta is 0 to radius 2. So from there to pi over 6, that took us back to 0. Remember, our theta is pi over 6. So our pi over 6 would look something like that with a radius of 0. And then from pi over 6 to pi over 3, we went from 0 to negative 2. That's how we went from where we were here to here. Okay, so that's our pi over 6, negative 2. Remember, negative 2, if this is 2, negative 2 is the opposite direction. Okay, then we went from pi over 3 to pi over 2, which took us from a radius of negative 2 to 0. So that negative 2 came back to 0. And then from pi over 2 to 2 pi over 3, right up here, pi over 2, 2 pi over 3. That took us from a radius of 0 to 2. So that's how we went from a radius 0 to a radius of 2. Okay, then we went from 2 pi over 3 to 5 pi over 6, which took us from a radius of 2 right back to a radius of 0. Then we went from 5 pi over 6 to pi, which gave us a radius of negative 2. Okay, so this would be your sketch. Alright, so hopefully this made sense, and I will see you on the next video.